Okay, so a simple torque problem, right? Remember, torque equation is tau, right? The thing there, it doesn't really matter. That's not a test question or anything, but tau equals force times distance times sine of theta. Right, so let's just do a couple simple ones. Let's say we've got a little guy here lifting a weight, right? So this motion right here, right? That is a rotation motion. The fulcrum, right? The point about which we're rotating, right, is the fulcrum, is right here. We're going to say in general, his arms are 0.8 meters, 80 centimeters, which is a fairly long arm, right? The force he's lifting, let's put that in terms of newtons. We'll say it's 40 newtons, which is about 10 pounds. And we want to know what is it when it's in three different positions, hanging straight down, right? So if I'm drawing him, right, like this, straight down, when it's at a 45, and when it's at a 90, right? So what's the weight when it's here? What's the torque on his arm when it's here, here, and here, kind of thing, right? So that's just going to be our force equation 3 different times, or our torque equation 3 different times. So we do force, 40 newtons, times 0.8 meters, times sine of theta, sine of the angle. Well, the angle is the difference between the force and the distance. Well, what direction is the force when you're holding up a weight? That force is down, and your direction or the distance is down. So the difference between those two would be 0. So you do 40 times 0.8, which is 32, times sine is 0, which is 0. So 32 times 0, 32 Newton meters times 0 is 0. So the torque when you're holding it there is 0. Now, it doesn't mean your arm's not applying a force. You're holding it up to keep it from dropping to the ground, but you're not applying any torque, which is why it's not rotating, right? So the first one there would be 0. What about the 45? Try and do that one on your own first. So I would just say torque again is 40 newtons times 0.8 meters times sine of 45. So we grab our handy dandy calculator, because I don't want to do sine of 45 in my head. That's a hard one. 40 times 0.8 times sine of 45. Make sure you're in degrees, not radians or anything like that. And that's going to give you a torque of 23 Newton meters. Right? 23 Newton meters for that one. If our weight was more, our torque would be more. If our arms were longer, our torque would be more. And then we see as our angle increases, our torque went from 0 to 23. So there's more torque being applied here than there was here. Hopefully it kind of makes sense, right? You can just hold or farmer walk or shrug a lot more than you can do an arm fly with, right? And so then we do this last one. Tau is 40 newtons. That's 0.8 meters times sine of 90. Sine of 90 we can just do in our head. That's 1 times 32 is going to give us a torque of 32 Newton meters. So it's the most when it's out here to the side, right? That should hopefully make sense. So a nice simple torque problem there. Hopefully that helps us review torque if we need it.